So I've started building a roller for our the ski club, like a big roller that has uh, like that packs down the snow. Um, the designer for it, Eager, my friend Eager, um, he did a fantastic job of it. I'm not a professional fabricator, like got a few trades behind me, so I'm not terrible at it. But yeah, so anyways, I'm just starting to weld the frame together. He has a bunch of details for like some sheet metal stock and some uh, like an axle that I'll have to turn or get somebody to turn for me. I can probably do it, but I don't do much work on the lathe. Anyways, so I'm just starting it, and this is the this part right now is just the start of the hitch bar with this tube which goes crossways. So we're going the T. So next I'll be after I get this tacked together, I'll be putting together item number 3 there on the drawing, which is a couple of jibs. So anyways, yeah, we'll see if this works. So I've made some good progress on this roller. Um, like that's the main part of the frame done. Now I'm working on doing um, sort of ears and fittings, and I have this plasma cutter. Like it was, I think, a couple $100 off of Amazon, a Chinese one. I got to hook it up to my compressor. It doesn't have its own compressor, but I'm actually kind of pleased with it. Like if I have a guide, it cuts really well. But if I don't have a guide, it can kind of get all mangled up. You can kind of see some of my practice cuts. So um, it just takes practice is really what it takes. But like it slices it like like a knife through butter. Um, this cut 50 is what I've got. I think it was one of the cheapest ones on Amazon. But like I've said it before, the Chinese are like it's amazing what they can build for the cost. Anyways, so yep, still working at it, making some progress. I think I'm just going to cut this off with the chop saw, and then try to cut my. I need to have a sort of an ear for it, so just working at that. I wanted to show a thing that I did with my plasma cutter. So I built an adapter cord here um, that allows this my plasma cutter to operate on 240 volts. The cutter has the capacity to use 120 or 240, and I can't remember what the amperage rating is on it. I should tell you here somewhere. So at 120, I guess 28 amps kVA. 50 amps at 80%. No, that's the on the power factor. Anyways, 28.8 amps, which I don't have a 28.8 amp or 30 amp 120 circuit available. But you know, by Kirchhoff's power laws, you double the voltage and you half the amperage and you get the same amount of power. And because it can take 208 and 240, I connected it to my 240 plug, and this is a 50 amp plug. That's the 50 amp receptacle right there. So what's happening is that it's 240 going into this box. Inside this box, I have two fuses, one on each leg of the power. And I forget what they are. I think they're 40 amp fuses, whatever the max rating of this was. And then this just plugs straight in because they didn't give me this connector. And I sent them an email asking why. And they said that because they sell all over the world, they can't provide the receptacle plug because of all the different configurations, which, well, it's like, yeah, but you know, it's going to Canada. So anyways, so I put this on so that I have the opportunity to, or possibility to use 120 or 240, depending on what's available. But in my garage, I'm going to always use 240. So with this coming in, the two fuses in here, the voltage that's actually traveling through this is 240. So in a normal plug, this would be your hot and this would be your neutral. But in this case, both of these are energized at 120 or 110, whatever my household voltage is. So yeah, so it minimizes the voltage, or the current, correction, the amount of current going through the cables. So just something been working really well. The other thing is learning how to cut. You can see here I have several different cut attempts. This was the latest one. I found out, so I've broken a couple things on the nozzle here. This white ceramic I don't know what this would be, like a holder, I guess. I broke that. And when I took it apart, I saw how it works. The air that comes through is actually comes through. It must be like sort of an annulus within the handle, or an annulus within here, goes into this. The air is just on the other side of this. I think it can't come through this section. Like this is a seal right here, and then is forced through the nozzle, the tip of the nozzle. So this is ceramic, which makes sense because it gets super hot. But it's also quite brittle, and I had broke one by dropping it, and you can see here, and it wasn't pushing the air through here, so I was getting really bad cuts. And as a result of that, like, I was getting slag and everything. On my other nozzle, this little nozzle here, it had plugged up and gouged out the end. So I suspect I could probably just file this down and it might improve the orifice here. But I put a new one in, and then figuring out different voltages, or sorry, different amperages. I'm trying to learn that. And then your other adjustment point is this regulator, which moves the amount of air in through it. And I've set it to what I've read is what it's supposed to be. I can't remember what it is. Maybe it'll tell you. It's got to be less than 5 CFM, because my compressor can keep up with it pretty much, and my compressor that I'm using is 5 CFM, so it's less than that. But anyways, yeah, just it does make a pretty nice cut. Like, I don't think you could cut this sharp with an acetylene very well. Like, it would, the acetylene torch would take a pretty big, or bigger, I should say, slice out of it. And this one, it's like about 1/8 of an inch is how much it takes out, so you're losing less material. But anyways, that's my plasma cutter. So I've been making headway on my roller project, as you can see here. This is sort of the main roller frame. I think I might have shown you the hitch that pulls the whole thing. But mainly what I've been working on over the last little while are cutting the sort of reinforcement pieces for the hitch and the roller itself. So there's some gussets here that I've been putting in, um, and then some angle plates here just to give everything some reinforcement. So I've been making these with my plasma cutter and this is some 1/8" flat bar, and my plasma cutter has been like doing a really good job of cutting through it. You can see these nice crisp cuts, that yeah, really slick. So just cutting them out right now. I'm working on some ears. um, Generally what I've been doing is cutting out the bulk of the shape and then grinding it down with an angle grinder I have, and then sort of using a file to do the fine parts of it. I don't have a bench grinder, which would make it easier, or like if I had a milling machine, that would make it a lot easier too. You could kind of zip stuff along really fast, like once you got it sort of cut out to roughly where you wanted. But this is going okay, a little slower, but still pretty good. I've I've got some plates that need to be part of this roller, and it's about 13.5 inches by 103 inches, and I didn't want to buy a whole sheet of 1/8" plate, so I had the idea that I would buy flat bar. These are two 6-inch pieces, and then I have another 1.5 inches that I've got, and just weld them together. Um, I saved a bit. Like it'll be about maybe $150 in saving, but the amount of time that it's taking me to weld it, grind it, weld it again is it would have been way better just to buy the sheet. But it would have been a little tough for me to manage by myself. It's 168 pounds according to um, the vendor. I am using this, so this is like a magnet for the ground on the grounding electrode on the welder. I don't remember ever using it before, but it's working really well. So trying to keep it as flat as possible. That attempt to weld the flat bars together to make the long plate that I mentioned earlier, it didn't work out that well. The welds went okay, but it was just a lot of work. I got about halfway through it, and I'm like, it's this guy right there, and I'm like, this is not working. So I ended up, I'll like eat the cost of the of those two flat bars. There were 6-inch flat bars, and I bought a sheet of 1/8" 4x8 sheet. So I just cut this with my plasma cutter, the whole length here. The problem with these sheets is that they're 8 feet, 96 inches, and I'll need it to be 103 inches, so another 7 inches past that. So I'm gonna have to cut a section out of this and weld a chunk on here, which is going to be a lot easier than trying to weld the whole length. Because I found what was happening was with the flat bar in there, as it laid nice and flat, but as you welded it, it would kind of curl in places, and it was hard to keep it flat. And then, like, I used up a lot of rod to weld it, and then had to grind it down, and then re-weld it, and blah blah blah. But anyways, so this is my cut. So I'm just kind of like moving it up and down to break it free, and then grind this down nice and smooth, and go that way. But yeah, ended up buying the sheet, which was about $300. the two sheets together, the two six like to make it without buying a sheet was about, let's say $140. But then there's like all that time involved, and then plus it's not very good. So yeah, this should be a lot better. Well, there's the plate that's going on the roller body. Um, this is where I welded that section onto it. Anyways, the two plates, there's the 13.5 inches and then the 5-inch section. I drilled these holes as per Eager's design. So that's where comb gets attached. Anyways, yeah, so that's our the plate. I'm just tacked it all in, and then now I'm just sort of doing the filler weld of these sections here. So nice, slow, fat beads. I'm using 7014 for that. Mostly everything else I used was 6011. But that 7014 gives a nice slow weld, and like a big puddle that you can kind of push around a bit. Because of there's a little bit of filler that I need to do here, which that 7014 makes that easier. So you can kind of gap that all together and make a nice. You can build it up with the 7014. Yeah, I think 7018 is the low hydrogen one. I tend to stay away from all that stuff like the 6011 and the 7014, just because I'm not a welding all that much, and you need to keep all that stuff in like an oven and whatnot. So I forget what the exact details of it, but it holds the steel together for my purposes. So the roller continues. The latest thing that I've put on is this this piece of angle right here. Eager must have designed it so that the corduroy attachment, what sets the corduroy when you sort of slide along, which will go underneath of here, so the corduroy will sort of stick out like this. He must have wanted it to be a lot more beefier than just the sheet metal here. So I've got that on. It's pretty much welded in. I've just sort of been tacking this in places here, like not fully welding it. The main reason I think is so that we can give it a place to drain, because obviously it's going to be in a snow roller. It's going to fill up with snow and melt, and so it'd be good to have some place for it to go. But other than that, yep, it's progressing. The last main part is a large, or not a large, just a chunk of angle that sort of runs in here. Yeah, I think that's to beef up whatever. He designed some fingers that essentially will go into the roller like this. The roller is a corrugated piece of plastic, and will be the fingers kind of go in there to knock off any snow that plugs it up. Um, so today I had a bunch of, well, not a bunch, a few parts cut by a local firm here. The cut shop is the name of the place, and they Eager, my friend who designed this, he was able to like his CAD software generates what was DWF drawings, and I just emailed them to the cut shop, and then the guys over there just put them in the computer and cut the stuff out. I supplied the steel, and what the service they provide was really economical and super fast, and just an awesome service. Like there's no way I would ever be able to even come close to being able to do anything like that with my plasma cutter. But they were, yeah, it was a great service. Super clean. They do it with a water jet is what they do their cutting with. I assume maybe they do other. I didn't go into their shop. I was just outside the whole time. But yeah, the cut shop. If you ever need some cutting in Calgary. So my the roller frame here is um, the major structural parts are on it. This last piece that I put on is this angle right there. I have to drill some holes through it. And that angle, what it is it's a support for some, I don't know, wait, I guess you'd call them teeth. So the roller is corrugated culvert, plastic culvert, and the corrugations are fairly deep. They're probably 2.5 inches deep, something like that. And Eager's idea was to have um, a rail, I guess, of plastic teeth that would stick out, and they would go into the corrugated roller, into the corrugations, and essentially keep it relatively clear of snow. So that's what this angle here is for, just to provide some extra, I don't know, durability. So those teeth, which I still have to get made, I think there's a place at work that does plastic CNC work, and I'm going to see if they'll do it for me, or if they'll have a recommendation for somebody. Anyways, those teeth will lay in here and then project like this, and then the roller rolls in this section here. So yeah, so just have to, like I say, drill holes through it so that we can bolt them to it. So this is the roller starting to take shape, or the frame starting to take shape. We have the hitch here, and then the main frame. And what we'll have in the middle of this main frame right here is the roller material. So what I've been finishing up on is the attachment points of the hitch to the main frame. So I've been welding these ears on from the hitch to the main frame. And so if you look here, you can see their ears. They'll be these will be bolted together. The way they're set up is that the hitch can pivot on the roller's main frame. So those water jet cut ears, they've been welded onto the pieces here, as you can see. So this will be bolted. So what I'm working on now is the actuator. So there's going to be an actuator that will be between the hitch and the main frame, and that actuator will cause this section here to sort of raise or lower to pivot around the roller wheel, I guess you could call it, like the culvert part. So these ears here are where the actuator will be connected between the two pieces. So these ones here will be mounted essentially around this area. Eager had designed these ears. There's two of them cut, and they were just to be put close together to provide one single. I'm not sure what you'd call the main point. So there'll be a clevis here, and then on this side, just a shaft on the actuator. Igor has the actuator. I'll have to grab it from him because I kind of want to see how it all goes together. But yeah, so These ears will be like this, and then, like I say, we have a small linear actuator. It's electric driven, 12 volt, which we have. We run 12 volt cable, a 12 volt cable back from our Skidoo, or our we have a Defender, and we can use that to raise or lower the implements on our pull equipment. So anyways, yeah, so next up I'll be welding these ears, these bigger ones here. So continuing along. So here are the various ears on the main frame. So we've got the two on the end, which are the connection points to the hitch. You would have saw that earlier. And then here is the actuator ear assembly. So it consisted of these two large ears, and then a support spacer, or webbing, I guess that's a better term, webbing in between of the two ears to give it, this sort of. Oh, it's still hot. I just welded on it. So this here, Eager would have designed it so that this point and this weld gives it the strength if it were going in a rotational direction like that. So that backs up and that backs up, and then this webbing here gives it the strength for the lateral motion. So yep, Eager thinks of everything. I've completed the cap and the cap assembly. So what it consisted of is this here, which is an axle, which is inserted into the bearing here. This pillow block bearing is just mounted to the frame. So yeah, this was a colleague. I was going to do it myself, but a colleague at work is a millwright, and so he's a little better with lathes, and he also did the attachment here to the cap. He's like I say, just I asked him if he would do it because I had it all set up, so he was willing to. A lot faster, probably better quality. Anyways, so now I have to, what goes in between of the two caps are a length of 3 lengths of channel that are bolted into those holes there, and that's to sort of provide structural rigidity, I guess, to keep them from going this way, and also that angle, it will be bolted into the roller material, the HDP plastic material itself. So anyways, I wanted to get these on so I could measure them and get a good distance as to between these, so to make them all exactly the same, so we get make these two caps a nice parallel surfaces to each other. Igor had provided dimensions, but I wanted to get these on and measure it before the dimensions are if my fit of welding and fitting of the tubing here isn't perfect, they might be off a little bit, so I just wanted to get it on and measured. So yep, looks pretty good. They spin pretty good. I think the sheet might be a little bent in places, which is another reason for having like that angle to sort of push it all into places. Like if you watch it roll here, you see how it kind of does a little bit of wobble. So like the sheet was bent while it was in place. The end of the angle that goes on the inside between the wheels here, or the cap assemblies as Eager calls it, are they're fastened to it using these pieces. So what that consists of is a little piece like this, a little square piece about 1 3/8 with the little corner cut off, and that fits in there nice and tight like that at the end of the interior angle. So just weld that, and then you've got a hole. I need to drill these out. I'm waiting for some confirmation on sizes from Eager. But anyways, so that's how the interior angles are fastened to the caps. So I've painted the rollers assembly here. Nice trim clad yellow. It's kind of a combination of spray and brushing. Wherever the spray couldn't get in or didn't work well, I just used a brush to brush it on. Nice thing about trim clad. And everything else has been painted as well that I've had made. So the caps have been painted, and then the hitch. Right now, I'm making the hitch portion of the that will attach to the drag equipment, so like the snowmobile or the Defender. And the way that I'm going to do it is our operations manager wanted some sort of release or a shear pin. So I'm going to put this in between the two, which will act as a shear pin. So I'm going to weld this into here, and then this will be drilled for a connection on other stuff. So anyways, for the hitch, and then going in between will be some sort of shear pin. The shear pin needs to be fairly long because it has to go through a 2-inch, which is actually kind of hard to find. Most of the shear pins I see available are for snowmobile augers. Or not snowmobile, snow blower augers. So I may have to make my own shear pin. We'll see. Here's the hitch attachment. I've made it as you can see. I've kind of made it so that it slides in here. This pin will go through here. It's kind of a little wobbly. We'll see. Anyways, and then there will be a piece in here with a eye bolt that sticks out this way, and that piece can come up and down here to adjust the height to attach to a different height of equipment. So that way we kind of keep this more or less the same angle. But anyways, we'll see how it works. I made a bit of a mistake when I built it to Igor's design. He actually had it up around here. So I'm missing like a hole, but anyways, I might be able to make it work. We'll see. So here's the roller pretty much assembled. The final hitch needs to be put on, but it's works pretty good. So the actuator's up. Hopefully that actuator is long enough. We'll see. Igor modeled it, so it should be done. But fortunately, I was a little worried about this not matching up, but it fit in essentially a little tight, but pretty good. Like, but rolls nicely. So, yeah, I think we're looking pretty good. It's heavy. But we'll see how that, this is about the height right here that it sits at. So with when it's on the skidoo, it has less lifting weight than I thought. I'm probably pushing on it maybe, I don't know, 25 pounds or so. So yeah, I was a little worried it was going to be lifting up the back of the skidoo and we'd lose traction on the skidoo, but yeah, this isn't too bad at all. So anyways, now I got to finish up the hitch for it, and then wire on the connection for the controls. This is the boss that I need for my hitch. This here is just a it's about 3/16 and a 1/2 inch diameter, and it's just so that I can set this into my piece of tubing, square tubing that will go in between my hitch attachment. And then this I just threaded or drilled so that I can I'll drill this out at home for my eye bolt. But yeah, this is just the boss. So that's just to center it, which will be, I'll drill 1/2 inch hole where I want this to be centered, drop that in there, weld it on, and then drill this the rest of the way out and tap it for my eye bolt. So I have the roller connected here and wired up and ready to roll. I've tested it and it's working good. So this is the one of our this is a controller I made for our other actuated pieces of equipment. So to go down, you hit down, and then as you can see, the bottom of the drag part is being lowered. So there we are, fully extended. So that probably, if there's a lot of snow, that will lift up the roller a bit. And then, so that's, we're in drag mode right now. And then we want to bring it back up. There we go. So then it lifts the back end, and now we're putting more weight on the roller itself. Here's the actuator fully retracted. Right there. And we'll go look at it. And it's lifted. So at this point, this would be the maximum amount of weight on the roller. Let's go down again. That's up. So down. Actuator extending. And fully up. That's as far as it should go. I don't think we're binding anywhere. Nothing's binding there. That's not binding. Yeah, so we should be good. Let's see if this is actually lifted off. Doesn't appear to be actually lifted off. So we might not have quite enough to fully lift this all the way up. Might talk to Igor about that. We might be able to extend this a bit. So, but it's touching all the way here. So maybe just because we're on uneven ground is the reason why it's not up all the way.